Greetings of the day. Welcome to the course on Operations Research Technique. Students, we have finished 3 units. From today, we are starting unit number 4, that is project management. This particular aspect, project management, is very important in our day-to-day life, and this project management practice has wide implication and application in operations research for decision making. There are so many areas where the concept of project management is used in real life situation. So as the name implies, project management, so this project management comprises of 2 words. One is project and another is management. So project itself is something which consists of or comprises of several activities which are to be executed in well predefined order. And when we talk of management, so any project, it goes through 3 important phases called as planning, scheduling and controlling. So overall monitoring of the project, starting from planning to its execution and controlling the same project at various points, is management. Now we'll see the contents and further requirement in the unit number 4, that is project management. Before that, it is must for student to get conversant with various terminologies involved in project management. This particular aspect is also referred as network models. In the language of optimization or operations research, project management problems are solved by the concept of network analysis, and that complete area is referred as network management. When we talk of network management, we basically come across 2 important words, abbreviations. One is PERT and another is CPM. PERT stands for Program Evaluation and Review Technique. Other is CPM, that is Critical Path Method. Both PERT and CPM comes under the aspect of network model. So network model basically comprises of 2 areas. One is PERT and other is CPM, Program Evaluation and Review Technique, and another is Critical Path Method. Now where to use PERT logic and where to use CPM logic is a matter of discussion. Now when we talk of any project, when we talk of the word project, so project may be a new project, may be entirely a new project where you don't have any earlier data available for analysis regarding various activities of the project. Some projects may be of repetitive nature, that is, we did one sort of thing and similar set of things are to be executed. So we are well aware that okay, this much particular activity will take this much time duration. Means we are well sure that this XYZ activity will be completed based on earlier data available within given set of time. But suppose we are thinking of any research project. Now in research project, you never know that when you are going to get the result. It may be possible that we get result at immediate, after some few days, few months, or it may take altogether some years to get the final derived implied result from the research project. There uncertainty plays a lot of important role. Means you are not sure that this particular project will be completed within this much time. If I am carrying out research on particular area, I am not sure that this particular research will be completed within 6 months, within 6 years, or within 50 years also, if it is entirely a new innovative concept which is beyond our imagination. Miracle may happen, but time, you never know that this particular project will be completed within this time. So when things are not within your control, when you are not sure that this is the probable time of completion of the project or this is the confirmed time of completion of project, you go for either PERT or CPM. When it is probability based, that you are not sure, but you know the sequence of activities to be performed, we prefer PERT, Program Evaluation Review Technique. But when you know, confirm that okay, this particular activity will take this much time, deterministic in nature, no bias, in that case we will use critical path method of analysis through network models. So let's say what is written: network models which comprises of program evaluation and review technique. I have written this with brown color, and critical path method, abbreviated as PERT and CPM, is used in planning, scheduling and control of the project. In the very beginning of this lecture, I have clarified the term project management, and under that I have used these three words: planning, scheduling and control of the project. Any project for sake will have these three important activities. This is first, second and third task to be followed in order for entire execution of the project. What is the meaning of each and every term? Planning implies developing overall layout of project. So this is the task which is carried out on paper with certain knowledge. You plan your task, entire project on a paper with estimates of time and resources. Students will be coming across these two important terms throughout this project management. Many a times I will be using the term time and resources. Project management cannot be completed without these two terms, time and resources. Whatever we are planning for different activities on paper regarding estimates of time and resources, these needs to be scheduled. And once scheduling is done, whether things are happening during execution as per our plan is in real term called as control of the project. Control takes place during work of the project, means during execution of the project. So this is in nutshell what the network model comprises, what is PERT and CPM, and what we mean planning, scheduling and controlling in any project. Further, now again, this is addition to previous slide. These techniques, these means again which techniques? PERT and CPM. PERT and CPM, these techniques helps the management to determine expected project duration. Very important. Expected project duration date, its scheduled start and completion time for different activities of the project. This is very important. When we talk of any project, now students, you must be knowing, Nagpur under metro phase 2, government has sanctioned metro line from Lokmanya Nagar metro station to Hingna metro station, which runs from the road via Yashwantrao Chauhan College of Engineering, Nagpur. Then Wanadongri is the area, and then it ends at Hingna. Now, on paper, government has done some calculation. Parties have submitted DPR. The meaning of DPR is detailed project report, with all inputs to the project in the terms of finance and output from the project, that after spending so many crores of rupees, what will be the outcome from this project, how the society will be benefited, and what will be payback of that particular project to which the money is being poured. Once that is calculated and estimated, then the project, the person who is performing on that particular project has to give that how much time will be required to complete that particular project with its start date and probable finish date, and the entire duration required during the project. Now, when we say a project, don't get confused with your curriculum project, that is maybe pre-final year or final year project, which we do in as per need of our curriculum. So project here, what we mean is entirely a big task which is to be performed in some well-defined order. Suppose I say construction of a house. Yes, it is a project. Construction of a bridge. Yes, it is a project. Construction of a dam is a project. Anything which involves number of activities, and those activities consume time as well as resources, that entire task is referred as a project. Means it has some activities which can be called as tasks, which needs some resources. We know 5 M's in engineering. We have many a times iterated these 5 M's: man, machine, material, methodology, money, and additional time. Time is a constraint. So project planner has to give expected project duration date, that is time frame within which you will be completing that project, when you will be starting that project, when he will be completing that project. Further paragraph says, critical activities of the project which must be completed at scheduled time. I will focus your attention on this. Critical activities of the project which must be completed at scheduled time, and time period by which non-critical activities may be delayed without causing, this is a very important statement, without causing any delay in the project. So now focus our attention on these two terminologies: critical activity and non-critical activity. Yes, we have seen what do you mean by project, and we have also seen project consists of number of activities. Amongst those activities, some activities are critical activities. Now we know the meaning, important criteria regarding the meaning of this word critical. Means we have to have our focus, full attention on this particular activity, critical activity. We know in medical term critical care unit. We know one term general ward. We know the other term ICU, intensive care unit, like that. So when we say the patient is in critical care unit, means he needs a lot of monitoring from team of doctors, from team of nurses and experts in medical field to monitor his deteriorating health, so that his health improves over a time. Means we cannot neglect the patients which are in critical care unit, must be monitored thoroughly. In the same aspect, students, in the same aspects, for a project, suppose there are 100 activities. Out of those 100 activities, maybe depending on nature of the project, 20 activities may be critical, 50 activities may be critical, 35 activities may be critical. Barring critical activity, rest of the activities are non-critical. The meaning is management, whosoever is controlling the project, has to keep always attention on critical activities of the project in terms of monitoring of various resources, management of various resources to the specified critical activity. And mind well, you are not supposed to delay the occurrence of critical activities. Critical activities must be performed within stipulated time only. But there are chances that non-critical activities of the project, depending on the situation, may be delayed, I am using the word, may be delayed by some time duration, and the decision maker can take advantage of shifting the resources of those non-critical activities to other activities where things are to be optimized. Got it? So important term, critical activity and non-critical activity. So critical activity needs a lot of attention from the management, whereas non-critical activities may be delayed depending on the situation. That we'll see through example. Now, where is the origin? All this, in our very first lecture we have said that operations research was originated during Second World War. At the same time, DuPont company developed a model called as critical path method, where the activities of this particular firm were deterministic in nature, while United States Navy developed PERT. This naval operation was related with warfare, means limited availability of warfare means not sure how the things will happen, and then they tried their level best, okay, with some probability aspect whether that result can be achieved, and they got success. And looking at their success, then other industries started using the model PERT, which was developed by US Navy. So this is how these terms CPM and PERT, which were coined, was developed by DuPont company and US Navy respectively, and nowadays they are widely used as a main tool of operations research technique or optimization technique. Now, before we go for mathematical analysis, it is very essential that we know each and every term involved in this network model. So I will be explaining all the term in detail. Once we understand the meaning of these sentences written, further things will be easy to understand. Mathematical analysis will be very easy. So network, it is a graphical representation of logically, again the word logically and sequentially connected arrows and nodes representing activities and event of the project. So this is definition of network. I will explain through this very simple diagram. Suppose students, what I have drawn is a network. What I have drawn on the board is a network. Now to understand what is written here, let me take opportunity. Again I will be explaining these things in detail in further part. Suppose I write here like this. I have written over arrows A, B, C, D. Students, these arrows, straight line arrows, are referred as activities, and these circles are referred as event. So activity, see here I am giving connection like this. Activities are represented by arrows, and here I have represented this for your understanding like this. Here it is given nodes. Nodes represent events, and here for your understanding this circle is event. So what I did is I have drawn 1, 2, 3, 4 activities. What is the definition says? It is graphical representation of, this is graphical representation of logically and sequentially. Logically, and suppose here the logic is B and C greater than A is the logic for this particular network. The meaning of this logical statement is, it is written B comma C greater than A, means indirectly A is, this is nothing but in other way A is less than B comma C. The same, this is or, means this or this meaning same. The meaning is, unless and until we complete activity A, I cannot start activity B and C, or B and C depends on A. That is the meaning, and that is what is logical relationship. And sequentially, so in order, that first A, then B and C, then D, like that. That is called as sequence. So that is the meaning of this It is graphical representation of logically and sequentially connected arrows and nodes representing activities and events of the project. So what I draw up to this point was representing a network. Okay, now project. It is combination of interrelated activities which must be executed in certain order before entire task can be completed. It is combination of interrelated activities. Now this small diagram which I have drawn is a network diagram for this project. This is network diagram for the project which consists of 4 activities A, B, C, D, which will be executed in sequence, and it will start at one point, it will end at one point. So this is start of this particular project, and this is finish or end of this particular project. So here this project will start at this point, here the project will end at this point. So we have seen 2 definitions. What do we mean by network and what is project? Project is nothing but it is combination of interrelated activities. Now let us consider these things, 2 things, activity and event. Students, I will first explain the meaning or the concept of event. What is event? It is nothing but it is starting or end point of a certain activity. Event as such does not consume any time. It is the instant of time. It is the point. It is a particular point at which activity starts and a particular point at which activity ends. How this can be explained? I have started this particular lecture at one point of time. When I have started the lecture at particular point of time, and then I said, greetings of the day, welcome to the course on. Before that point, a fraction of point, I have started my particular lecture. That does not consume any time as such. It is instant. Neither it consume any resource. At that point. But since then, from that point onwards, till this time, what I am doing? I have consumed some time. I think approximately I have taken 30 minutes of lecture. Means I have consumed till time 30 minutes and I have consumed some energy of mine. To deliver lecture, I have consumed my energy, which is resource for this particular case. And during last 30 minutes, I am continuously delivering lecture by consuming my energy is referred as activity. at one particular point of time I will be stopping this particular lecture, I will be ending this particular lecture at particular point of time, again that will be event, and I will stop delivering the lecture. But from this starting point to end point, this is starting event for the lecture, this is end event for the lecture, and this entire span I have consumed some time and some energy. Like suppose I want to represent here, this is starting, this is end of lecture, and this is the time duration where I am delivering my lecture. So this is suppose start of lecture, this is suppose end of lecture. Assuming that lecture duration is suppose 60 minutes. So time consumed by the activity referred as taking lecture is 60 minutes, and the resources uses energy of the person who is delivering. Resource. So this particular portion is activity, this is event, this is also event. So let's see. Activity is a physically identifiable part of the project which consumes time as well as resources. Suppose, simple example I will quote. We know in construction of house the manpower requirement is there, and we know mason is there, and suppose he is carrying out operation of laying bricks on the beam to construct wall. Like suppose the beam is ready on the foundation. Suppose this beam is ready on the foundation, and you want to have some wall constructed, so he will lay bricks like this. This is activity. This is activity which will consume the time for that activity of construction of wall, and it will consume some time as well as it will consume some resource. It will consume some resource. So this is physical. We can see with our eyes that a mason working on the site, I can notice that so much of time is consumed. Also, so much quantity of material is consumed, which we refer as resources. So activity is physically identifiable part of the project which consumes time as well as resources. Got it? Now students, event. I have given one example of conduction of this lecture. Suppose, to understand the concept of again event, many a time on road we find that one vehicle is coming in this direction very fast, one vehicle is coming in this direction very fast. They are out of speed, and at a particular point of time what will happen? They will collide with each other. So the instance, the point of time where the two vehicles collide, which we call as accident. The accident has taken place at fraction of seconds, at a point of time. That is event. Next we know what will happen. So people will rush, people will gather, then there will be mechanism. Somebody will call police station, somebody will call ambulance, somebody will help the injured. Different activities have started now. As a result of this event of accident, I have discussed so many activities which will start simultaneously, and at one point of time nobody will be there. That event called as accident is over. So starting and end with in between activities. So remember, any activity will always have starting event as well as end event, and in between those two events will be a activity. Now this event and activity in operations research concept is represented by straight line arrow that we have seen in previous slide. Again we will see in further slides. And events are distinct achievement at the point of time and does not consume any time. So one thing you have to keep in mind in this PERT and CPM analysis, whenever it is event, event will never consume time and resources, but when it is activity, it will always consume time as well as resource. Keep this in mind. Now, right from the beginning we are saying PERT, CPM. So what is the precise difference? Let's discuss that. In the very beginning, I have explained that when we are not certain regarding how much time the activity or task or entire project will take, when we are not sure, we will go for PERT. So not sure means probability. When your nature of the project is probability based, go for project. But when it is deterministic in nature, always go for CPM. Students, I will explain this concept in very simple example. Deterministic. Suppose I am builder. I have earlier constructed 10 flat schemes. I have mastery over each and every aspect of flat scheme element. I know how to procure land, I know how to procure, from where to procure material, resources, I know how to manage all documents from government office in legal way, and I know that this particular set of activity will require this particular set of time. And therefore what I can do as a planner of the project, as a builder, that I will give the entire details of the scheme to my clients. This is the particular scheme I am launching on Phalana and Phalana date, and this will be executed after some particular time, say a span of 2 years or 3 years. There we will be using the aspect of CPM. I am again and again underlining this deterministic word because we are sure that construction of house, construction of flat scheme, construction of dam and its various related element will take this much time only. We are sure we will go for CPM. Second is very important. In PERT, since it is probabilistic in nature, we will come across 3 time estimates. PERT model will always come across with 3 time estimates: TO optimistic, TP pessimistic, and most likely TM. So O optimistic, P pessimistic, most likely M. The sequence is, students, most of the time, suppose TO, TM, TP for a particular activity. If it is 5, 8, 15, suppose the unit is in days, means optimistic time I can finish that activity is say 5 days. No, I am not sure. I don't think that we can finish that activities in 5 days. So what? Considering all the aspect, okay, it will take 15 days. Pessimistic, not very sure, okay, maybe like that. Farthest one. And in between, not exactly in between, between optimistic and pessimistic is most likely. So this follows 3 time estimates, whereas only single time estimate is in CPM model. Say I say, suppose I want to construct 100 square feet wall as a builder. Looking at my past experiment, I know how much time I will need for this activity. If it is 2 hours, only it will need 2 hours. It cannot be completed within half hour. It will not take 5 hours or 6 hours. Builder knows that standard mason, average mason, any average mason will take this much time, and calculations go by this concept only. Probabilistic nature, PERT, it is referred as event oriented, whereas this is activity oriented, and we have seen what we mean by event and activity. To draw on the paper, length of activity arrow is proportional. Now if it is deterministic CPM project, since it is deterministic, we are sure how much time each activity will need, and therefore we can have a proportionate network with all details of only one time estimate of the all activities. But since it is multiple activities are there in PERT, the length of activity arrow may not be proportional. That is the difference. Very important, the projects which belong to the category of research and development, where you are not sure about when end will occur, prefer PERT. But when you are very sure, as I have repeatedly said, in construction industry, we know that this much activity is taking this much time because the work is monotonous and repetitive. Go for CPM. Got it? PERT, CPM, both under network models. Next. Now, PERT, and this is explained, but I will give gist of this. PERT CPM network components and precedent relationship. We have coined the term precedence, that is one after other, logical and sequential connection of the nodes and activities. Now events we have seen, it is distinct point in time. Activity we have seen that it is represented by straight line arrow. So going further, before that, suppose I want to now event is represented by circle. It is also called as node, N-O-D-E. Now suppose I consider this as an activity suppose I write here I write here J. So I and J are events. I and J are event. I is starting event, J is end event. And these starting and end events are connected by straight line arrow, which is called as activity. Straight line arrow, which is called as activity. So what we have to remember, this circle is referred as event. This is also referred as event. This is end event, whereas this one is start event. Start event, ith event, end event, jth event. These two events joined by this activity. So activity starting point is I, activity end point is J. Activity name is given above the arrow, that we'll see. But remember, for the time being, what I am emphasizing is activity by straight line arrow, like this, like this, like this. And we know one common sense, time always flows from 0 onwards. When I am drawing the network, my flow of activity arrow will be from left to right, because left to right will give only progression, development. Now this activity here, this portion is referred as tail and this is referred as head. So arrow is towards head side, reverse side is tail. So activity is having two dimensions, tail and head. Head is always associated with arrow, arrowhead. And important, what is this? Node or other name event. What is that? Node or event. Node or event. Students, you must understand these two terms if you want to thoroughly understand the concept of PERT and CPM. What is node? What is activity? Or are there any difference between node and event? No, both are same. These events or nodes are in analysis numbered by Fulkerson's rule. We'll explain, we'll see how this Fulkerson's rule helps in numbering the events of any project. Again, I am saying a project may be a combination of 1,000 activities which are to be executed in predefined order. There we will go for the aspect of PERT or CPM in both, important, in both analysis, PERT and CPM, we will be considering activity as well as event. Methodology for finding the timing of the project in both cases is same. Only interpretation and application analysis wise is different. That we'll see when we will take numericals. Now, see here, what we discuss is event, and these events are of two types. Events are of two types. What are those two types? That we'll see. Some events are merge events and some events are burst event. Merge means activities, more than one activity will terminate at that particular event, is merging. Bursting means simultaneously many activities coming out of the event is bursting. Anonym of each other. Merge versus burst. Incoming of all activities at event, this is many times I have referred this is event. Now this event has these activities. This event has these activities, suppose 3 activities, C, D, E. All 3 activities are merging in this event. It may be that further, depending on the situation, you may have some activities emerging from this. That we'll see. But right now, focus your attention on merge event. Merge event. Now, other is burst event. See here, same event. Now, from same event, 3 activities are shown. Let it be, suppose A, B, C. The meaning of this is activity A, B, C can start at the same time. You have choice of starting activity A, B and C at same time. That is the meaning of this particular burst event. Whereas the meaning of this merge event is we cannot say this event completed unless and until all C, D, E are completed. Suppose you complete activity C and D and still your activity E is yet to get finished. It is not yet completed. We cannot say event is complete unless and until all 3 activities which are merging into that event are completed. This event cannot be said as complete event. Got the meaning of merge and burst event? Let's move ahead. Now, the numbering of the events in the network diagram must start from left of the project to the right of the project and from top to the bottom. Care should be taken that there is no duplication in the numbering. So as said earlier, this particular rule was framed by scientist Fulkersons, and what he said, that while numbering the events, adopt policy of numbering from left to right, because time flows in forward direction from left to right and top to bottom, and do not duplicate the number. Means suppose you are writing 1, do not repeat 1 to other event. How that we'll see with example. Now here I have written Fulkerson's rule. Let's understand what the rule states. Fulkerson's rule. Suppose I draw a simple network for the project to understand the concept of numbering the events. This is a very simple example for understanding purpose. Suppose this is the network. Now you must know that any network will have straight line arrow and these events. Now I want to number these events. So I will tell you simple logic. What the rule says? It says start from left to right. This is one key you have to keep in mind, and other is top to bottom. Keep these two keys in your mind. Top to left to right, top to bottom. Time will flow, network will flow in this direction. So count the number of events 1, 2, 3, 4, 5 without hesitation. Students, this is very important. Without hesitation, give first event as number 1, last event as number 5, because we have counted total event 5. So this is starting, that is finish. Now what it says, left to right, top to bottom. So you have to see the emerging or bursting activities. Now this particular event is bursting event, and the other important point is give for the event for which you want to give the number, it should have only outgoing arrow. It should have only outgoing arrow. If it is having outgoing arrow, give that node or event as next number. And to give that event as next number which is having outgoing arrow, how to consider that? I have numbered this as 1. Now this event is having these two activities. I have to concentrate from left to right and top to bottom. What I will do? I will assume this as deleted and I want to number this. So see, if I put my palm like this, this is only indicating me this is outgoing. So 1, 2. Other from this is top to bottom. Emerging from, say, again if I hold my palm like this, this is having 2 outgoing arrow but no incoming. So logically this will be 2, 3. Left to right, top to bottom. I have given number 1, 2, 3, 5. Only number remaining is 4. So this is what in simple term we will see again complicated problem for numbering the event. So once we are aware with concept of Fulkerson's rule, numbering the events, we will be in a position to solve the problem and draw the logical diagram. So here we will stop today's lecture at this point of time, and in next lecture we will see further part of this discussion. So I am ending my today's lecture with this background.